Hello again, chemistry class. Today we're going to do section 8.2 notes. And to start us off, we're going to go over something that was also in section 8.1. In forming covalent bonds, electron sharing occurs so that atoms attain the electron configurations of noble gases. And let's look at what that means. Alright, so we have here hydrogen is going to pair up with hydrogen. And the electron configuration, if you remember, of hydrogen is 1s1. Okay, so I got that configuration 1s1 from our periodic table here. Remember, this is the S block right here, group 1A and group 2A, and hydrogen is the first element, so it's 1s1. Alright, so the other hydrogen will be 1s1. Now, these guys want to be like, if you remember, helium. There he is. And he is 1s1 and then 1s2. So they want to be like helium. Make sure this is going to show up, which is 1s2. Alright, so that's what they want to be like. And so we're going to pair these guys up. And let me get my markers here. We have hydrogen, and that's purple, and we'll have a red hydrogen. And we're just going to put them close together. And what we said yesterday was this hydrogen can now count both electrons because he's sharing his, the red one's sharing his electron with the purple hydrogen, and they can count both of them. And if they're counting both of them, that means their electron configuration is 1s2 for the red guy and 1s2 for the purple guy. So now their electron configurations are just like helium, a noble gas, and everyone's happy. Something else I want to show you today and introduce is that instead of writing out the dots for the bond every time, we can draw them a little differently. We're going to just draw a hydrogen and another hydrogen. Instead of drawing the two dots, we're just going to draw a line. We can now do that, okay? That's going to quicken things, and that's how you're going to see it most of the time. Whenever electrons are being shared, they can just be drawn with a line. Alright, so let's continue on. Okay, so the next vocab term that your book gives you is the structural formula. It's just a representation of the covalent bonds with dashes and shows the arrangement of covalently bonded atoms. It's basically the electron dot structures, but there's another vocab term for you, structural formula of molecular compounds. Alright, so let's do more examples. This is just like the hydrogen we just drew out. We're going to just show you that it doesn't have to be hydrogen every time. So let's pair up F2. We're gonna make F2. We have one fluorine and another fluorine. The electron configuration of fluorine is 1s2, 2s2, 2p5. Remember, fluorine is in the P block over here. So he had his 1s1, 1s2. He had the first S filled up, then 2s1, 2s2 filled up, and now he's over here in the P block. 1, 2, 3, 4, 5. He has 5 in the P block, and that's what we drew right here. He wants to be like neon, his electron configuration, so he wants 1s2, 2s2, 1, 2, 3, 4, 5, 6, 2p6. So they want, both of these fluorines want to be 1s2, 2s2, 2p6. Now let's draw the structural formula. Let's draw the electron dot structure just with the lines now. So we're going to have fluorine. And you draw the ones that are not bonding as dots still. and then we'll draw a line. This line represents the 2 electrons pairing up, or being shared, I should say, by the 2 fluorines, and that's what we draw. Simple as that. Okay, let's try one with, it's not a diatomic, let's try 3 hydrogen coming together with a nitrogen. Let's try that now. So I didn't draw out singly all the hydrogen, I just wrote 3 hydrogen. Let's do this. So, let's put nitrogen in the middle. It can be easier that way. Draw his 2 unshared electrons. Now that all the others are going to be shared with hydrogen. And so remember that hydrogen was a 1s1, and now that he's sharing 2 electrons, he's a 1s2, and that's like helium, and that's what he wants. Nitrogen, on the other hand, is 1s2, 2s2, 2p3. That's his electron configuration before bonding. Now after bonding 3 times, he has the electron configuration of nitrogen's green. So let's stick with green. So nitrogen has 1s2, 2s2, and 2p. So he added 3 electrons. So he was 3. If he adds 3, he has 6 now. And that is just like neon again. Because neon has 1, 2, 3, 4, 5, 6 in the p orbital. And hey, that's just like fluorine attained in our example prior. Alright, let's keep going on. So, I keep on talking about the bonds, and I say, okay, the shared pair, and then I say these unshared pair. There's another vocab term that you need to know. Unshared pair of electrons, also known as a lone pair of electrons. A pair of valence electrons that is not shared. Pretty straightforward there. So, here's an unshared pair, here's an unshared pair, here's an unshared pair. Those are all lone pairs. The electrons that are being bonded together are not unshared pairs, so that's pretty basic. Our next vocab term, single bond. It's when 2 atoms are held together by sharing a pair of electrons. So it's like all the examples I've shown you before. This is a single bond, this is a single bond, this is a single bond, this is a single bond. Only 2 electrons for 2 atoms are being shared. So here, hydrogen, nitrogen, 2 atoms are sharing 1, 2 electrons. Fairly simple. Alright, and I can draw another example here. Let's do propane. So I'm going to draw out propane. He has a lot of single bonds. All these, oh, this is one. So all these lines represent single bonds. And we're going to learn other types of bonds here in just a minute. Okay, so our other types of bonds. We have double covalent bonds and we have triple covalent bonds. And they're pretty much what they sound like. So in oxygen, whenever oxygen bonds with itself, we have one oxygen here and then another oxygen here. Oxygen has, if you look on the periodic table, okay, I'll lead you through this one more time. Lithium, beryllium, 1, 2, 3, 4, 5, 6 valence electrons. Alright, so you get the valence electrons by counting on the periodic table. So, they have 6. So let's draw in 2, I think here, 4, 5, 6. Now I'm going to draw these at an angle because they're going to spread out a little bit. And 1, 2, 3, 4, 5, 6. If you didn't, that's fine. You would see it. You need to do these in pencil because you'd see it after you wrote them down. Alright, so This oxygen wants 8. This oxygen wants 8. Everyone wants 8 because they want to be like noble gases. So let's make a bond. Alright, we have a bond now. Alright, let's count this oxygen. He has 1, 2, 3, 4, 5, 6 of his own, and then he gets to count this guy over here. 7. He is not happy. This oxygen, 1, 2, 3, 4, 5, 6, and then he can count the other oxygens. 7. He is not happy. So a single bond does not make O2 happy. O2 has to bond 2 times. Now let's count electrons. This oxygen can count all of these electrons, and the other oxygen can count all of these electrons. Alright, so the purple circle guy has 1, 2, 3, 4, 5, 6, 7, 8, and the red one has 1, 2, 3, 4, 5, 6, 7, 8. So everybody is happy. Everybody has 8 in this O2 example, and that's a double bond. We have 4 electrons total. That's 2 pair that are involved in the bonding. Okay, let's show you a triple covalent bond. Very, very similar.